By expressing f of x as partial fractions, find the binomial expansion of f of x in ascending powers of x. As far as the term in x squared, give your answer in its fully simplified form. So the first question is to represent f of x as partial fractions. To do that, the first step is to factorize completely denominator. So we need roots. We should consider denominator to be equal to 0, and it's quite easy. Roots are -4 and -2. Hence, x squared plus 6x plus 8 can be represented as, formula is ax minus the first root multiplied by x minus the second root. So it becomes a is 1, so it is equal to 1, x minus minus plus 4, and x minus minus 2x plus 2. If it would be not polynomial of degree of 2, but for example polynomial of degree of 3 or greater, if you know all roots, hence such polynomial is equal to ax minus the first root multiplied by x minus the second, and so on up to x minus the last root. If, for example, it's a polynomial of degree of 3 and there is only one real root, hence such polynomial can be represented as x minus root multiplied by another polynomial which will be of degree of 2 and q of x. This polynomial can be found as initial polynomial divided by x minus root. So for our problem, f of x becomes, f of x is minus x minus 8x plus 4x plus 2, and it will be splitted into the next fractions: a over x plus 4 plus b over x plus 2. Why such fractions? We can see that there is a polynomial of degree of 2 in denominator and polynomial of degree of 1 in numerator. When degree of polynomial in denominator is greater, you get only fractions. For example, if it would be minus x squared, you can see in numerator polynomial of degree of 2, in denominator also polynomial of degree of 2. If you divide these polynomials, you get constant, so it would be a and fractions, and each fraction corresponds to each parenthesis. So it would be a plus bx plus 4 plus cx plus 2. If it would be, for example, x cubed, so now we have polynomial of degree of 3 in numerator and polynomial of degree of 2 in denominator. So if you divide, you get a polynomial of degree of 1. So it must be polynomial of degree of 1, and it's ax plus b and plus fractions cx plus 4 plus dx plus 2. And why is there just a, just constant? Rule says that in numerator must be polynomial of degree 1 less than in denominator. There is the polynomial of degree of 1 in denominator, so in numerator must be polynomial of degree of 0, and it's just constant. If there would be x squared plus 4, it means there is in denominator polynomial of degree of 2, so in numerator must be polynomial of degree of 1, so it would be ax plus b. For example, if it would be x cubed, so in numerator there must be ax squared plus bx plus c. And if you have, for example, x plus 4 to the power of 3, there must be all powers of x plus 4, so there must be x plus 4 plus b x plus 4 squared plus c x plus 4 cubed, all powers from 1 up to 3, and then dx plus 2. So for our situation we get that f of x is just a over x plus 4 plus b over x plus 2, and we need to find a and b. To do that, we just consider again common denominator, and in numerator we get a x plus 2 plus b x plus 4. Hence, negative x minus 8 should be equal to a x plus 2 plus b x plus 4. You actually can open parentheses and equate coefficients in front of x and just numbers, but let's use another method. Since it's true for any x, it will be true for some specific value of x. So let's consider x to be equal to negative 2, so that we we get 0 together with a, so it will be 0. On the left hand side we get minus 2, it's 2 minus 8 is b, negative 2 plus 4, which is 2b. So negative 6 is 2b, b is negative 3. So b is negative 3. And to find a, we can consider x to be equal to negative 4, hence it becomes 0, and we get 4 minus 8 is a, negative 4 plus 2, which is negative 2, a, negative 4, a is 2. Hence, answer is 2 over x plus 4 plus minus 3 or minus 3, it doesn't matter, x plus 2. And the next question, to get binomial expansion, we should use formula for binomial expansion with the rational power, and formula is 1 plus x to the power of n is 1 plus nx plus n minus 1 x squared over 2 plus n minus 1 n minus 2 over 6x cubed. Here actually 2 factorial, which is 2, and here is 3 factorial, and you can see, I hope you understand pattern, and you can continue if required. but we need up to x squared, so we need only these three terms of this expansion. But also provided that x magnitude, absolute value of x, less than 1. It's important. And to use this formula, we should represent x plus 4 as x plus 4 to the power of negative 1. It must be in numerator, and minus 3x plus 2 also to the power of negative 1. And to use formula we need 1 plus something, so you should make 1 plus something in numerator. So continue. It is equal to 2, and to get 1 plus something we factor out 4, but it is going not just as 4, but it will be also to power negative 1. So 2 times 4 to negative 1, and in parentheses we get 1 plus x over 4 to negative 1, and minus 3 do the same, 2 to negative 1, 1 plus x over 2. And now we can apply formula, and we can simplify 2 times 4 to negative 1, it's 2 divided by 4, it's half. And expansion is 1 plus nx, n is negative 1, x is x over 4, plus n is negative 1, negative 1 minus 1, negative 2, over 2, and x squared. X, it means 1 plus something, and it's x in this formula. So for our situation, it's x over 4 squared, plus so on. We need only x squared and no more, minus 3 over 2, and expansion of 1 plus x over 2 to negative 1. Again, 1 plus nx, negative 1, and x here is x over 2, plus n, negative 1, negative 2 over 2 x squared, x over 2 squared. And we need just, and so on, and we need just simplify it, and actually we need the final answer in ascending powers up to x squared. So we need just simplify it. So it is equal to half x minus x over 4 plus 2 over 2, 1. So it is equal to x squared over 16, and minus 3 over 2, 1 minus x over 2, again plus 2 can be cancelled, and plus x squared over 4, open parentheses, and get 1 over 2 minus x over 8 plus x squared over 32 minus 3 over 2 plus 3 over 4x and minus 3 over 8x squared, and just add like terms to get finally that it is equal to negative 1 plus 5x plus 8 minus 11x squared over 32. And the next question is find the values of x, range of values of x for which such expansion is valid. So we should consider, we know that this formula is valid for magnitude, absolute value of x to be strictly less than 1. And what is x? X is this part 1 plus something. So we have 1 plus x over 4. So x over 4 by absolute value must be less than 1, but also x plus 2 must be also less than 1, and it should be simultaneously, and it becomes x over 4 greater than negative 1 or less than 1, and x over 2 greater than negative 1 and less than 1. Multiply by 4 here and by 2 here to get x is negative 4, x is greater than negative 4 and less than 4, and x is greater than negative 2 and less than 2. And solution for both inequalities, we get that x is between negative 2 and 2. I use set notation, it means set notation. So this expansion is valid for values of x between negative 2 and 2, not including endpoints. And that's all for this question.